Using a graph to solve system equations is an excellent visual tool. So we can always graph the lines and where they cross a solution. However, a lot of them aren't set easy to graph. Easy way to graph is when they have y by themselves. They're not all going to be like that. So we're going to do the method substitution. And this is a flow chart here. And I point this out. This book does a good job of putting things in steps. If you're a steps person, it does a good job of helping you with that. So here it tells you, choose a simpler equation and express one variable in terms of the other. What that's telling you is, in the one that I gave you, it already had y equals x plus 2. That's one variable in terms of the other. The y is by itself. So you want one variable by itself. Okay, that's what step 1 is. Step 2, substitute into that variable to the other. That's what we did. We took x plus 2 and we put it in for y. That's step 2. Step 3, solve. Step 4, plug in what you got to get the other one. It's that simple in terms of the steps. Now in terms of doing it, it takes a little bit of time. All right, let's go through these. Consider the following system equation. I have x plus 4y equals 17, 2x minus y equals 7. Solve the system using the method substitution by rewriting the first equation in the form of x equals. Okay, we'll start with you, Logan, so we have to go around the room today. See how they're talking about x plus 4y equals 17, right? How would I get the x by itself there? Okay, so here's the x, right? What's the thing next to the x I don't want there? How do I get rid of a plus 4y? You know, right? Minus 4y, minus 4y. X equals a negative 4y plus 17. That's what they wanted me to do. That's step 1. This is step 1. Is that the only one you could have done? No, look at the second one. See how there's a y down there? I also could have solved for y on that one and got the same thing. I could have isolated that variable if I want. You can isolate x or y. It doesn't matter which one you did. That one we had y, this one we had x. It doesn't matter, just one. Pick one. Okay, solve the system using the method substitution by rewriting the first equation in form of y equals. Okay, oh wait, we need to actually solve it. Sorry, we're not done. So, Hannah, where am I going to put this? Not for y, for x. It is an x, right? So we take this and we put it right there. Here's the thing that you need to write down, actually. I want you to write on the side. Don't put back into the same equation. What I'm saying is, we got this from this guy. If we plug it back into there, all your stuff will disappear. All your things will cancel. You get 0 equals 0. You'll be like, what happened? That means you put it back into the equation you got it from. Okay? Do not, when you get something to substitute, do not put it back into the one you got it from. Okay? Do you want me to show you why or no? No. We're good? Okay. If you want to try it, go for it, but do not put it back into the original. So do not do this. Okay. So here we go. 2 times this. Minus y equals 7. So there it is. I plugged this right there for the x. Now we distribute, and we're going to solve for y. Okay, here we go. Distribute. I'm going to come over here. Negative 8y plus 34 minus y equals 7. Negative 8y and negative 1y is like terms. That's negative 9. All right, we'll stop there. Ollie, what would you do next? Good. Minus the 34. Negative 9y equals negative 27. Spencer, how would you finish it? Okay, what's the negative 9 doing? Dividing, right? It's multiplying, so you want to divide. Y is 3. So I got y is 3. Jose, how do I figure out what x is? 3 plus 4y. Yep, good. Joe's right. She's right. She put the 3 in there for x, or for y. Excuse me. Did you put it for x or for y? Okay, so sorry. We put it for y because that we solved for, right? However, I'm going to give you something that's a little bit easier to do. You see right here where we've got x by itself? We're going to plug it into here because once I put it in there, it's going to kick out the answer right away. We already got the work to isolate x, so use that isolation. So we're going to take this 3 and we're going to put it right there. So then you can see what's negative 4 times 3? Negative 12 plus 17. 5. X is 5. Okay. Okay. I think some of you guys probably think it's a little bit easy, so I want you guys to try it now by isolating the y. Okay, I'm going to give you some seconds here. So right here, get that y by itself and do the same thing the other way. I'll pause the video and let you try it. First thing is, some of you guys, that's why I see where the fraction question is coming from, Logan. You need to first off figure out which one would be the easiest to solve y for. Always take the one that doesn't have a number next to y. So we don't want to go for this one. Let's go for this one. Yeah, so what we're going to do is we're going to go ahead minus the 2x, where if negative y equals negative 2x plus 7 is where you should be. Yeah, life's a lot easier that way. If you do the other one, you're getting fractions, and yeah, fractions are still possible, but let's avoid them if we can. Okay, divide by negative, so that just changes all the signs. So this is my y equals. So then I take this, I put it right there. So I get x plus 4 times 2x minus 7 equals 17. Let's talk about this out loud real quick, because this is our first lesson. Give me this step we're at right now. We just did step 1. Okay, excuse me. This was step 1. This is step 2. Can somebody just come up with some things where they know their step 2 is wrong? Just tell me something where you're like, I know that's wrong. That's not right. Just think about how you could. 2 different variables. If you still have an x and a y, you did something wrong, right? Okay, good. What else? Is there anything else you can think of? What's the one thing I said earlier could happen if you plug it back into the original? Yeah, you get 0 equals 0, right? Okay, so there's some 2 options when you know things aren't going well. Okay, so now from here, guys, it just, to me, again, I know I say this and I'm not being insulting. This is back to Math 9. This should be clockwork. Okay, boom, boom. X equals 45. Divide by 9. X equals 5. That matches. That's great. Again, take that 5 and put it back into that one where you isolate already. Put it right there for x. Okay, so Lauren, what's 2 times 5? 10. What's 10 minus 7? 3. We got the same answers. Okay, down there at the bottom, verify. Okay, what you do to verify is you take x and y. I'll let you do this on your own. You take x, plug it in. Take y, plug it in. So if here's the first one. 5 plus 12 is 17. Check mark. 2 times 5, 10. Minus 3 is check mark. Okay, that's how you verify. Okay, you can go ahead and do that there, and we're just got some examples in the back, and then we'll take a break after substitution. Okay, substitution's not bad. I prefer elimination, which is the next one. These are all different methods of solving. Check the solution using a graphing calculator. So let's do that really quickly. How would we do it with a graphing calculator check? We need to have them both in y equals form, right? So the one, Travis, that one you did where you solved for y, that'll actually help here. Okay, so we need to put these in our calculator now. Let's do this really quickly. This one we had y equals 2x minus 7. That's your y1 or y2, doesn't matter. this one, 4y equals negative x plus 17. Divide 4. In your y2, you're going to put negative 1/4 with a bracket, x plus 17 over 4 bracketed. That's a 4 there. So try that and do the intersect feature to figure out where their solution is. You're going to tie this all together. Okay, I'll pause it while you're doing that. I'll be around to help with the calculator. All right, good. Moving forward here. So we just have this last page. All right. So we just have these couple. All right, stay with me, guys. Okay, we have 2 more examples, and then we'll let you have a break before we do elimination. What's that? It's another method of solving. Okay, it's the one that I prefer. Depends. I don't know. I like it a little better. It's a little quicker, but can get confusing. So we'll have to wait and see. I'll let you choose. Okay, consider the following system equation: 4x plus 3y equals 0, 8x minus 9y equals 5. Solve and verify the system using the method of substitution. So this is one where you need to solve for a variable and you're going to have fractions. Okay, there's not a way to avoid fractions here because you have a number next to all your x's and y's. If you're not sure what I'm talking about this. 4, 3, 8, 9, all in front of those variables. Okay, so I have no variable that's nice and friendly right now. Okay, so in general, Mr. Stanich, just tell me, we'll go with the 4x plus 3y. Do you want to solve for x or for y? And there's not a wrong answer. You're just telling me what to do. Y. Okay, so we're solving for y. 4x plus 3y equals 0. I'm solving for y. Minus 4x. Divide by 3. Y equals negative 4/3 x. Sure, you put plus 0 if you'd like. Okay. So, Travis, where am I going to put the negative 4/3 x? Right there, correct. Into the y, the other equation. Okay, so here we go. I have 8x minus 9, plug it in. Everybody okay with that? Yeah. Okay, so here you go. See how it's a minus 9? Treat that as a negative 9, okay? So what's negative 9 times a negative 4? Positive 36. And what's 36 divided by 3? 12. Is everybody okay with that? No more fractions. Okay, 8x plus 12x is 20x. Divide by 20, we have a fraction answer. That's okay. X is 1/4. Yep, now we put it for the x, yep. So we'll take this right here. Remember, use the one you isolate already. Put it right there. Put it right there. So here we go. Y equals negative 4/3 times 1/4. Okay, Denise, how do we multiply fractions? Straight across, right? Negative 4 over 12, which is negative 1/3. Okay, verify it with your graphing calculator. So the only thing you have to do is, we need to solve this one for y real quick. I'll help you. Minus 8x divide by negative 9. Okay, this is what you're putting in. That's one of them. This is the other one. 1, 2. Put those in and confirm that you'll get 1/4 or 0.25 and negative 1/3, 0.33 repeating. All right, good job. You guys checked that. I saw a lot of 0.25s and negative 0.33. Good. One more example, and like I said, we'll have a little 5-minute break before elimination. Okay, consider the following system equations. Uh-oh. There we go. All right. So 5 times 2a minus 3 plus b equals 5. 6a minus 2 times b minus 4 equals 20. So first off, who cares a and b? It's the same thing as x and y. Okay? Just think of a as x, b as y. Okay? So we're going to say in our mind, I'm saying this in terms of if we want to like check by graphing, okay, or verify, doesn't matter. Okay, so what I'm going to do is I'm going to go ahead and distribute, but I kind of like this right here. That b is just hanging out by itself. So that I'm going to solve for b first, and not specific b. So I'm going to distribute. I get 10a minus 15 plus b equals 5. I'm going to move these over. Minus 10a plus 15. Okay, so b equals a negative 10a plus 15. I always swap these. I like having my variable first. Okay, so just a habit. This is going in right there. 20, yeah, 20, thank you. I forgot to actually add them, didn't I? Okay, plus 20, perfect, saving us up a mistake. Okay, so if you're saying, well, do I put it in now or after I distribute? It doesn't matter. You can distribute the -2 and then do it, or you can plug it in now, combine like terms, and then hit all the -2. If you're not sure what I'm talking about, I'm taking this negative 10a plus 20 and putting it right there. I could do it now or after I distribute. Okay? Ridge, what do you prefer? Now. Okay, so I'm putting it in now. So 6a minus 2, now I insert it. Negative 10a plus 20 minus 4 equals 20. So now I work out the inside there. 6a minus 2, negative 10a plus 16 equals 20. And now we distribute the -2. -2 times a -10, positive 20. Negative 32. Okay, I'll stop for a second, make sure that I'm not going too fast. Questions or concerns there, or maybe I have a mistake again? We're good? So I'm going to make this 26a. I'm also going to add 32 over. Gives me 52. Divide 26. A is 2. Okay. We're going to take that 2, and we're going to put it right here. So b equals, good job, negative 10 times 2 plus 20. Negative 20 plus 20. B is 0. A is 2, B is 0. Questions before we verify? Is that? Do I lose you? Never mind. Okay, so then we'll verify it. So we will put A is 2. So I'm going to verify it from this one. So 5 times 2 times 2 minus 3 plus 0 equals 5. 2 times 2 is 4. 4 minus 3 is 1. 1 times 5 is 5. 5 plus 0 is 5. So the first one's verified. We'll verify the second one. Okay. 6a, so 6 times 2 minus 2, 0 minus 4 equals 20. 6 times 2 is 12. 0 minus 4 is a negative 4, times negative 2 is plus 8. Verified. They're both verified correct answers. Okay, that is all for substitution. If you want me to do the enrichment with you sometime, it's just you have 3 of them. So you'd have to do the process twice. So like for example, I'll take this, I'll put it right there. Okay, then I'd take this one, I'd solve for y, get that one in for y. Okay, it's just one of 3 variables. Does anybody know, calculus, but anybody know what causes 3 variables in mathematics? You're in easy town right now. 2 variables is easy stuff.
Fractions.
No, fractions. No. No.
Negative numbers. 3 lines. Another variable.
He's close. 3 lines.
Cubes.
3 dimensions. 3-dimensional. All you guys deal with is 2 dimensions, x and y axis. Then what happens is, math, you have x, y, and then you have a z that goes through, so you can draw 3-dimensional figures. Yeah. You guys ready for that tomorrow?